On to the final presentation of the second day of High Load Armenia. So the answer to the question about how do you scale a Kubernetes cluster was obvious to me like 3 months ago, because you take cluster autoscaler and basically this is it. But now we have an unobvious answer. You can use Karpenter, which is a product developed by AWS. Viktor Vedmich from AWS is about to tell us about Karpenter and the scaling of Kubernetes cluster through Karpenter. Viktor, please.
Hello everyone and welcome to my session. Thank you very much that you joined my last session during the high load. So yeah, today we are going to speak about how we can scale, how we can use another approach, how we can scale Kubernetes through the Karpenter. So, but in general, before I jump into my presentation, I want to speak with you how exactly we can scale anything, like what exactly we can do inside the Kubernetes, how we can scale inside the Kubernetes cluster. So these two main approaches. I believe all of you know of them, but anyway, I want to highlight it a little bit. The first one is horizontal scaling. When I speak about horizontal scaling, it means I have one instance of my application, and if I need more, I will add more instances. Like, for example, I have one pod, I add additional pods, more and more and more. So it means like I can scale horizontally to extend capacity of my application. But and also I can interact with my metric server, understand like what's the capacity, what's the CPU utilization or memory utilization, and based on these metrics, make some decision. From another side, I can use vertical scaling. For example, if I have my pod, I don't know, like 250 millicores, and my Java application is working very hard, and I need more CPU, like 2 CPU, 3 CPU, I can scale through the vertical part of the scaler. Yeah, and it's a main baseline when I speak about the scaling. It's one of the biggest benefits when I speak about cloud, because cloud provides for us scaling horizontally and vertically. So we can extend, for example, capacity of my EC2 instances, just like virtual machines, or say I want to the biggest EC2 instance, like 100 CPU or 200 CPU and so on and so on. But vertical and horizontal part of the scaler allows to extend only internal the cluster, not outside. Like to add additional resources, we should currently use like cluster autoscaler. And as already mentioned, just like currently most popular solution, and I hope all of you use cluster autoscaler. Please raise your hand if you use cluster autoscaler. Please, yeah, finally someone just like, please don't sleep, final presentation, understand. So what's exactly cluster autoscaler is doing to add additional resources? There are 4 main steps, just like the first one, I get requests for new resources. So I understand that currently I don't have enough capacity. My scheduler didn't find some free spaces for current request. And cluster autoscaler will communicate with node group. Node group, it's like abstraction, which is not existing in the Kubernetes, but anyway, we connect to ISG, autoscaler group, and autoscaler group based on our configuration. And we remember that we have to define minimum, desired, maximum capacity of my ISG. So based on this configuration, based on this communication, ISG provide for us, in general, just like EC2 provide for us new resources. It can be one instance, multiple instances, doesn't matter. And we have new capacity, new resources where we can put our application. So it's how it currently works. But in general, let's view from another way. So currently I have a request of 7 pods. Every of these pods is requested 1 CPU. What exactly will happen with cluster autoscaler? As you can see, currently we have some amount of capacity which is free. Please move to another. I try to do some magic. So as you can see, we have some free resources, like some capacity inside of our resources. Yeah, and of course, scheduler understand like I have some free spaces for this request of resources, like for these 2 additional pods. But for all another pods, it will be in the pending state. And cluster autoscaler will connect it to a node group, ISG to EC2, and provide for us additional resources. But based on the best practices, we'll provide the same size of virtual machine. For example, in this case, we use 4 CPU, just like it's just like in this example, yeah. So we will create 2 additional nodes because we requested 5 additional resources for 5 pods, which requested 5 CPU. So what will happen in this case? So we'll put our pod inside as 2 additional new nodes. Yeah, but as you can see, the last pod, the last node is not just like the consumption of this node is not very good. I mean, like we will still have to pay for these resources, but idle of this is more than the half of this node. So Karpenter tried to solve this problem. The main idea of the Karpenter provided for you just-in-time resources what you exactly needed. But if you look at the in general of the diagram, what's really happened when we requested resources from cluster autoscaler and what's the difference with the Karpenter? So again, just like I have some applications, just like for example, horizontal pod autoscaler, or I deploy new application. As I mentioned, just like through the pending pod, we understand we needed more resources. We need more instances from the EC2, for example, and so on. And through the cluster autoscaler, which we also have to install inside our cluster, we add through the ISG, communicate summation to AC2, and AC2 provided for us this node. So if we compare the cluster autoscaler and Karpenter, my best comparison is like what happened in Kubernetes 1.24 when we totally decommissioned Docker as just like additional layer to communicate with containerd. In this case, Karpenter totally delete cluster autoscaler is not needed. It's not needed ISG. It's not needed create your node group totally. Yeah, you directly communicate with AC2 API, and there is a biggest benefit because when we can communicate directly with AC2 API, we can set what's the current instances available in this availability zone. Because when working with spot instances, I believe if you touch spot instances, you understand sometimes, for example, Netflix release new, I don't know, movie, and all of the resources from this availability zone, this specific type of instances is not available. I mean like spot instances. But maybe some another is available in this availability zone. But you have to manage like manually, I mean create additional ISG or define different type of instances and so on and so on. And Karpenter can solve this problem. Let's review the same example as from previous slides, how exactly cluster autoscaler add additional nodes. What will happen with Karpenter? Absolutely the same situation. I have request for 7 pods, and for these pods I need to provide the resources. Again, Karpenter works very good with scheduler. It's like the same with cluster autoscaler. Scheduler. Scheduler sees like I have some free places, some free resources. I can put 2 pods inside in these nodes. So let's do it. We finish all another pods in the pending state. And Karpenter understand I have the current request resources. Like in my case, it's 5 CPU, 5 pods, and directly communicate with EC2 and just like goes in through the list and identify what is the best instances will be to fit this load. I mean like I need 5 CPU, of course we don't have 5 CPU instances. So this means like we will provide, for example, 8 CPU instances. But as less as possible, we provide just in time load resources for your load. But currently, we speak only about the scale out. Cluster autoscaler works pretty good with the solution. But when we scale in, I saw many times situations that I delete all of my load, but cluster autoscaler still is waiting for something because we are waiting for ISG configuration and so on and so on. What will happen with Karpenter? Again, the biggest benefits, we directly communicate with EC2 API. We directly communicate with scheduler, understand what's really happened with inside my Kubernetes cluster, and just like we can react very, very quickly. Let's see exactly what will happen. So currently I delete my previous load, and I don't need some of the nodes. For example, this one is free, and I can delete this node. So in cluster autoscaler, it also will happen, but depends on the time. And during the demo, will be, I believe, will be very interesting if just like everything will be works. But anyway, so we delete these instances very quickly. What's the current mechanism Karpenter provided for you? The first one is node TTL. As soon as my node is free and I can delete it, we run TTL, time to leave. And for example, 30 seconds, 1 minute, we delete this node. But in August, if I right remember, we announced new feature, it's consolidation. And from my perspective, consolidation is one of the killer feature for Karpenter. What's exactly consolidation? Consolidation, so how currently Karpenter provide for us the load? So I have a request, I don't know, like 10 CPU, 20 CPU, and based on this request, I communicate with C2 API and provide the right amount of resources. But after that, Karpenter don't do anything like if I scale down, so previously we have an issue if I have, for example, one pod in very big node. But currently, Karpenter simulate the load every every minute, something like that, to understand if I request from the scratch the same amount of resources, how many nodes do I need? Like 2, 3, 5. Maybe I can delete some of them, for example, or I maybe request new node, which will be the cheaper, and moving the whole of my load to new load. Of course, you ask me just like in this case, if I enable consolidation, I can lose my application, of course. But if you're familiar with Kubernetes, you know what is for disruption budget, for example, and you can define, for example, I want enable consolidation, but avoid situations that, for example, 50% of my pod will not be available. Karpenter understand all of the constraints which you provide for Karpenter. We will see a little bit later what I mean like constraints for Karpenter. But what exactly Karpenter from physical perspective? Like what I should do to install and start working with the Karpenter? The first one is of course controller. Almost the same what we install in the cluster, like cluster autoscaler. And the second one, it's our custom resource definition. It's our provisioner, how exactly we are going to work with EC2 API and define some of the configuration. I understand like you cannot read it. A little bit later, I show what exactly we can configure in our custom resource definition in our provisioner. So first of all, we can define the purchase options. Purchase options means like, for example, I want to use only spot instances or on-demand instances. Spot instances much cheaper, highly recommend to use if your applications like allow it. The next one is, for example, CPU architecture. If you're not familiar with Graviton, IRM, highly recommend, just like it can boost your performance and provide very great opportunity to save your money. So through the Karpenter, you can define provision, just like I'm going to work only with spot instances or on-demand instances, and during the demo I will show you how exactly it works. For example, if I want to split my load 50-50, for example, 50% will be on spot instances, 50 on on-demand instances. The next one is instance type. Maybe you have some reservation plan or capacity plan, like and so on, or you know like your application works very good only on this type of instances. Yeah, so you can define I want to scale the same as we do on SG, for example, when we define the list of EC2 instances type which we want to run inside SG. The next one is availability zone. For example, if you're working with some application which is really strict in some availability zones, like for example in availability zone A and B, and you want to run all of your load only inside in these availability zones. I will be speed up and say like Karpenter understand also your VPC persistent volumes, yeah, PVC, PV, and for example, if you have some deployment which required EBS volume, and we remember that EBS volume is availability zones resource, Karpenter will also understand these constraints and provide it for you resources only on this specific availability zone. If you have your PVC like persistent volume claim, for example, inside availability zone A, we also request resources in availability zone A. Also, of course, we work with startup tains and tains. Maybe you're familiar with tains, maybe someone not familiar with startup tains. Let me explain what is startup tains. For example, I have an instance and I want to configure my CNI, like my network interface. And I want to avoid the situation that scheduler will proceed scheduling something to put on my node something new before I just like delete the startup tains. So startup tains allow us to don't schedule anything before I finish my load. For example, my daemon set, like Cilium, for example, currently is provides such kind of functionality. So I finish configuration as my daemon set and delete it. Another one, as I mentioned, we are working very good with different constraints with your scheduling. And for example, if you define the nodes selector or, for example, your node affinity, anti-affinity, it's worked really well. I mean, like inside in your deployment, in your pod description, your manifest, you can say like, I want to run only in some specific availability zone or not in some specific availability zone and everything else. Of course, you can create your own, like use your own custom MEI instances for your EC2 instances, yeah. And also, for example, just for some reason you want to define some user data, which is very needed for your workload. It's possible. Also, you can say, I want to use some MEI family. This is like, in my case, it's bottle rocket. Maybe you need to specify some additional configuration and so on, so on. Also, through the Karpenter, you can define it through the provisioner. You can define kubelet configuration. Why do we need it? For example, we have to reserve some amount of resources for my Kubernetes, for my system. For example, you have some daemons, and inside in your operation system, you want to reserve 1 GB of memory and some amount of CPU. It's also possible, and also it works very good with eviction, like eviction hard, eviction soft inside the Kubernetes. Also, we can just like define for our kubelet inside an every EC2 instance. Also, we remember that when we create new EC2 instance, depend on sites, it will depend how many pods I can put inside in this node. For example, if it's very small, I can put only like 5 pods because it's a network limitation. I can provide only 5 IP addresses, blah, 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 all of the stuff. What we can do just like with pod the density. So the first one is related to the static. So I can say, if I have like, I want to say like maximum 20 ports per my node, or for example, depends on the cores. For every core, please add 2 additional ports. Like, I don't know, if I run 60 CPU, I will be able to run 32 ports inside in my node. So, looks like I'm speaking too long. It's demo time. If you want to continue with me, you can scan this QR code. It's available on GitHub. And I'm going to switch to my console and show, just like explain what's the configuration of my demo. Yeah, it's like what I currently have, what's the configuration, and what we are going to do. So I hope you scan this QR code if you want it. I forgot to mention, guys, Karpenter is open source. It's currently have realization on EKS and AWS, but we are open and we are waiting just like some PRs from another cloud providers, and we have some hopes like maybe in the next year we will see some realization for another cloud providers. Who knows? But anyway, Karpenter is open source, and like if you see some issues, if you see some opportunity to improve, please go ahead. It's available on GitHub and so on. So what I currently have, I have 2 environments. The first one is my Kubernetes cluster, of course, and the second one, again, Kubernetes cluster. But what exactly I already installed? In the first environment, I installed my Karpenter as controller and provisioner. For this Kubernetes cluster, what exactly I have? Let's see, I have my provisioner, and we'll see only default provisioner. And let's see exactly what this default provisioner have on the configuration. Let me show you very quickly. So here, as you can see, I defined some amount of limitation of resources. So currently I say only 1000 CPU I allow to proceed with my provisioner, just like defined in this limitation, and also some additional requirements. Also, I install open source products. It's called like Kubernetes Operation View, which allow me to visualize what's really happened during my demo. So currently for first cluster, I have only 1 node. And in this node, as you can see, I have a couple of pods and daemon sets. So what exactly do we have? From the high level, we see like we have Karpenter to pod, and also I have my kubeops view, its Redis, and also application. So I have the same just like configuration for my second cluster, yeah. And here I'm going to run some performance tests. We are on high load. We want to run a lot of pods, yeah. And I want to show you how Karpenter works with high load. Just like requests of resources, and how quickly we will scale down as soon as we don't need these resources. So what exactly I have in this environment? Absolutely the same, yeah. I install my provisioner, I install my Kubernetes, install my Karpenter, and also my kubeops. As you can see, the same 1 instance. And what exactly I'm going to do? I have my bash script. Let me show you my bash script. It's here. I'm going to generate some load. So through this bash script, I will generate some amount of deployments. And in every deployment, just like based on the random, I will select some amount of resources, like for example, 250 CPU or maybe 1 CPU and some amount of memory. So let's run this demo and I will switch on my first environment. So let me quickly search. Yeah, so what exactly I'm going to do? I'm going to run 5,000 pods and just like in the batch. Every deployment will have 500 pods. So it means like we will run 10 deployments. So let's do it. And meanwhile, it's running. I hope it will finish like success. Let's wait a little bit. So we will see it's like a start procedure to request resources from EC2 API directly. So it looks like everything's good. I'm going to switch on my first environment. Again, what I have here. So I install my Karpenter, I install my provisioner. It's very default, nothing special. I'm going to use only spot instances, as you can see, yeah. And also I'm going to use only AMD's architecture from CPU perspective, yeah. And restriction related to resource. Also, as you can see, I enable consolidation. It's very important because if you define TTL, for example, to delete your instance, consolidation will not work. So just like it's excluded. If you want to use TTL, turn off the consolidation. So what exactly I'm going to do? I'm going to run my first manifest. It's very simple. Let me show you again. It's like how it looks like, and it will be so small. Yeah, it's here. So what this deployments looks like. So I'm going to run only 10 replicas. And it's like a very simple application, inflate, doesn't matter. What is really important here is like how many resources I'm going to request. 250 millicores from CPU perspective and 250 megabytes of memory. So let's run this manifest. Apply minus F, K, it's like kubectl, just in case if you're not familiar. And my manifest, it's start 10 pods. And I want to switch to another terminal where I want to show you what's really happened inside the Karpenter, how Karpenter react on my resource requests, what's really happened under the hood. So currently, as we can see, Karpenter understand like I'm going to run new instances. It will be CN INX large, and we will understand why. So Karpenter understand like we need to run 10 pods, yeah, because I requested 10 pods. But how many resources do I need? Karpenter understand it. It says like I need 2060, just like 2.6 CPU, but you ask me why so much, because Karpenter also understand and works correctly with daemon set. And we remember for every node, if I run my daemon set, I also need to provide resources for my daemon set. Karpenter understand it. So Karpenter requested from EC2 what the instances currently available to proceed with this load, and got around 284 instance types. It's really like pretty long list, and selected the cheapest one, which is available currently in this availability zone. And if I switch to my view operation, currently you see it's like I run new instance and put all of this load on these instances. It's my spot instances, and just in case if I want to scale this application, what will happen? Let's scale, for example, to 60 pods. So I want to add additional 50 pods for my application. So currently, if I request it, please show me my deployments. So I will see that for inflate, currently I have already scheduled 50 pods, but waiting for another amount of pods which currently don't have resources. I mean, like we don't have resources inside of my Kubernetes cluster. And again, if I switch back to console to logs from the Karpenter, we also will see that Karpenter understand. Currently, I need to provide just-in-time resources for 45 pods. And in this case, it's requested more than 10 CPU. And again, in this case, we got more than 200 CPU instances which we can proceed with these request resources. From visualization part, let's see what will happen. So currently, as you can see, I requested new node, but you remember that I enable consolidation, yeah? And magic will be happen just like, I believe, in a couple seconds or maybe in a minute. So what will happen? Karpenter understand like, okay, currently I requested pretty big node. This big, sorry, it's very difficult to read, but please believe me, these nodes have 16 CPU, and it means like I can proceed with, I mean like I can move my 15 ports from the first node to this one and save money for you, yeah, because idle of resources will be less. Also, we can see it through the very great plugin, which is like called capacity. So currently, as you can see, I have 3 nodes. Let me run my plugin. It's capacity, this one. So, and currently, if you run it, we can see already we have only 2 nodes. One node is reserved for my Karpenter, where I install my provisioner. And currently, as you can see, capacity, like how many resources I requested, it's almost 90%. And switch back to my visualization part, previous node was deleted and only one node left it. So, but you can see like I put all eggs in one basket. If I lose this one node, I will lose all of my load. It's not very good, just like because if we have some web application, we will better to spread this load between different nodes. What exactly I can do it? And it will be the second part of my demo. I will delete this load. Let me just delete deployment. It's my inflate, sorry. And also, as I promised, I want to show you how you can, spread your load between spot instances and on-demand instances, because it's very, very common situation which I had from the customer. Yes, I want to have some on-demand instances because it's guarantee for me that I will have 100% available these on-demand instances and nobody will take my spot instance, this on-demand instance. For this reason, I'm going to delete my provisioner. It's default provisioner. Let's do it. Default. Yeah. So currently, if I clean, just like to allow you to show you, if I try to get my provisioners, it will be like empty. I don't have any provisioner, but I prepared 2 another provisioners. It's called like spot and demand. What's the difference and what the magic will be happen here? So the first one, I define like capacity type for spot provisioner. Of course, will be use spot instances only. And also I say, please add additional custom label, capacity spread, 3 and 4. For on-demand instances, absolutely the same configurations, the same, like all other stuff. But I say on-demand type of instances and my custom label, let's call it this way, 1 and 2. But also, as I mentioned, it's not very good to put all of my loads in one node, yeah? I can use topology spread, of course. But from the Karpenter, we also can say, I want to run my pods, and the limitation of the pods will be 30 in my case. For example, I say for kubelet, for my nodes, please provide for me EC2 instances, which allow me to run only 30 pods inside in my node. So let's apply these 2 provisioners. I will hope it will be quickly. Cube apply, please. -f, provisioner. Sorry, not this one. It will be the final part. Provisioner, and I have spot, this one, and I have my demand. So in demand. So currently I have 2 provisioners. Yeah, on demand and my spot for my spot instances. And let's run another load. In this case, I want to run, let me show you what I'm going to run, this file. Absolutely the same, yeah, but in this case, I'm going to run 600 ports in my application, and with limitation. I say topology spread with max Q1. It means like I will spread my ports between on-spot instances and on-demand instances on the same amount. So through these labels, you can control how many percentage you want to run on the spot instances or on-demand instances. For example, for spot instances, you will say 1, 2, 3. For on-demand, only 4 and 5, for example. So it means like the proportion between on-demand and spot instances. Before we run it, like let's double check that currently we have only one instance. yeah, like where we run my controller, it's my Karpenter controller, and let's run this load. Again, very simple kubectl apply -f and file, and this one spread split this one. So I'm going to request 600 nodes. And again, if you look at the Karpenter logs, what's really happened under the hood, Karpenter will understand like, okay, currently like a lot of logs because I have different requested because as we remember 30 ports per node. And Karpenter understand also the logic like where ports should be located. As you can see, I requested some spot instances, some on-demand instances, and if you look at there, for example, from not from this perspective, let me run another one. No, not this one. We will see how many nodes currently I already requested, like from on-demand and from spot instances. And of course, we needed some time just like to provision these nodes, onboarding all of them, like install my kubelet, so on, and run to proceed with just like as soon as these nodes will be ready, we will see like what's the spread between on-demand and spot instances. From visualization part, it looks like in this way. Of course, my application open source. Looks like a lot of requests. Yeah, we have to wait, sorry. So anyway, just like what we currently see. We see Karpenter understand like I need to provide for you some amount of resources. And this amount of resources should be spread between, for example, different locations, between different purchase options, like in my case, like on demand or spot instances. And understand all of these constraints, depends all of these requirements, and provide for you just-in-time resources. And as soon as we will see some ready nodes, I will start to proceed with my load. Let's just like double check how many currently deployments, what's the capacity. I mean, like I already scheduled more than 400 ports inside of my Kubernetes cluster, and as you can see, just like it's going on. Let's double check from visualization part. Sorry, I cannot guarantee that open source will work. Oh, yeah, please. Yeah, so as you can see currently we have another spread how many nodes I have and how many ports inside of this node I put it. So if you look at the very carefully, you'll see like not more than 30 ports inside of every node because I defined this limitation for my Kubernetes cluster, for my provisioner, sorry. And if you look back to my amount of nodes, just like I will not calculate, you can test by yourself and see how many spot instances I currently have and on demand. So from this down, what we got it? We spread my load between different type of instances like spot and on demand, and did it very quickly. As you can see, less than 2 minutes, I start to proceed with new load of my resources. So, and as I promised, I have another part of the demo. Like if you remember, I have another environment where I run 5,000 pods and spread it between different batches. Let's double check what exactly I have currently in my default namespace. In my default namespace, as you can see, I deploy all of my pods, yeah, and just like then run it like less than 10 minutes, a little bit more than 10 minutes ago. And what's the most important? What's the capacity usage from these 5,000 nodes? Let's check with our capacity plugin. And yeah, so as you can see, 99%. So Karpenter provided for you 99% capacity usage. So it means like I try to find the best instances for the current load, yeah, and try to achieve the situation that I will not have some idle resources. You will only pay what you exactly use, just like avoid situations like what we had during the cluster scaler, because I can scale and have only one small pod and all another nodes like it is empty and idle. So, but it's not this demo. I want to delete these nodes, of course, because it's like it costs pretty a lot of money. So let's try to search. Yeah, not this one. Sorry. This one. So I want to remove. No, okay. Let me just 1 second. Sorry. So I have delete. Yes, delete. So It's also very, very simple batch script which identify like what's the deployment I have and start like deletion process, like remove all of these resources. And let's see from visualization parts how it looks like, what will happen and how much time it will take. And I will try to scale a little bit. As you can see, I have a lot of nodes, this one. And meanwhile, it's scaling, just like scaling down, scaling in. I'm ready to answer your questions.
A really interesting demo, but what about corner cases? In our production, we often see the situation when a node is not ready state. We have AWS node pod which not ready, and we see pods is Kubernetes stop publish status, and after that I expected Karpenter should move pods from this node to another nodes, but this is not happen. This is something wrong in our provisioner configuration, or maybe it's a default behavior for Karpenter.
Karpenter will wait for this node, just like some amount of money, some amount of time, yeah. And as soon as we achieve this threshold of the timing, we will delete this node and create new one. Of course, I understand like it's not acceptable if you have some critical load and you need to provision new resources during like 2 minutes. Of course, it's not acceptable. In this case, just like maybe to over provision or try to understand what's really happened, why this node exactly didn't just like touch to my connected to my Kubernetes cluster. You need to go deeper and understand what's really happened, why Kubernetes configuration was not configured inside of this node.
Okay,
And
but in our case it was from EC2 instances, and I don't think we can we can change something in this part of our configuration. Okay, so it's expected behavior.
Yes,
when node is not ready, pod will not reschedule it to another nodes.
Because we already have some events, and for this event we try to proceed like, as you can see in the logs, I show like I have requested for 45 pods. For these 45 pods I need like 10 CPU, yeah, and provide it for this node. And I try to wait for as soon as this node will be ready. Of course, it's like it's not ready during some amount of time. Try to decommission process like cardon, drain, and delete. You should, in this case, you can delete just like this node.
Yes, only manual delete node helps, but it's not acceptable for our workload.
It's logic under the Kubernetes and scheduler. Like Karpenter try to provide for you some resources and waiting for them. Just like if it's not acceptable, it's I hope that you can contribute and say, let's define the configuration and provision and provide for me the management of that TTL. Like 1 minute, 2 minutes. I'm not ready to wait for the more than 2 minutes.
Okay, maybe TTL for our Karpenter provisioner configuration, it's wrong. Okay, so I understood.
Meanwhile, as you can see, like I delete all, Karpenter deleted all of these pods and delete all of these nodes. Directly communicate with EC2 API. And I remember I have to show the last slide with QR code, and we'll be very happy if you provide some feedback from my presentation, and if you want to just like to read a little bit more about the Karpenter, it's very simple to find karpenter.sh.
Thanks for presentation. And is Karpenter track pod anti-affinity?
Yeah.
Yeah, and how it will work with, I don't know, in case when we run 10 new pods, how faster they can schedule all nodes?
Currently, the goal for the service team to achieve 1 minute to provide you a new node with constraints and requirements for this node. So you can say, I want to run this node inside some availability zone, or for example, you have some persistent volume. For persistent volume, again, we remember that it's EBS should be attached, availability zone again, and maybe some requirements, not affinity, anti-affinity, and so on. Karpenter just like pretty very quickly. But the main idea is just like to achieve 1 minute to provide for you this node. Node is ready and ready to schedule your pods inside in this Kubernetes. Is this node? In this node.
Thank you for presentation.
You're welcome.
Is Karpenter better than classic Kubernetes autoscaler only with consolidation or something else too?
Performance and provide just like less complexity of your management cluster with the scaler. I mean, like ISG, you have to create a lot of node groups and so on, so on. Of course, you will ask me just like what's the performance difference? I would say around 5 to 20%. Depends. It's not like significantly like 2 times. No, but it's best. It's faster because we don't communicate with ISG and so on. Like we communicate directly with EC2 API. The second point is, of course, spot instances. Because if you're working with spot instances, you should feel the pain, just like this spot instance is not available and this availability is on. What I should do? I have to manually to go to ISG and add additional type of EC2 instances, spot instances which currently is available. You can avoid this situation manually, just like Karpenter will do it for you, just like get the information from EC2 API, what the spot instance is currently available, and this availability is on based on your constraints. Again.
Okay, all-in-one solution. It is like autoscaler.
Yeah.
And autoscaling group all-in-one.
Yeah, and try to achieve consolidation, just like provide for you only what you exactly need from resources perspective. Of course, you can see the situations that if you provide some constraints, you put one port because based on your constraints. But the idea is, like as I show on 5,000 ports, achieve 99% of consumption.
Okay, and I have second question. How do you know max count of pods per node? Because in real projects, you always have different pods with different requirements.
Yeah, you can, first of all, you can manage to the provisioner. In the provisioner, you can do it like it's static pod density. Depends on how many, just like you define it, yeah? And also dynamic, like depends on how many cores do you have in this inside EC2 instance. For example, if I request very small instances, potentially I will be able to scale only 5 pods because it's a limitation from network perspective, how many IP addresses I can assign. So you can do it manually. In other case, yes, of course, you can be in situations that if you don't define, like, please don't scale for me more than 200 pods in one node, Karpenter can just like be in situations that you created too big node, yeah, and try to scale like less or more pod inside in this node. But anyway, you have possibility to control it, and also through the your deployment, you can say the topology spread. Please don't scale for me more than some amount of pods per node.
But where is the boundary? Is it not working?
What do you mean? It's like
I mean, if I have many consumers, for example, many pods that need too low resources, okay? And I can run about 300 on one node, big node. Usually boundary related to networking in this case. Is it main boundary for other cases too or not?
Yes and no, depends what exactly you want to achieve. Mostly when you define the pod density, like from the kubelet configuration, as I mentioned, static and dynamic, it's mostly related to the network, yes. But from another side, if you provide default configuration for your node, for your provisioner, you'll request very big node, like I know 100 CPU, and put all X, as I mentioned, in one basket. And if you lose this node, you lose everything. For that reason, topology spread, or say maximum amount of pods per node, not more than 30, 40, like depends. And go ahead.
Okay, thank you.
You're welcome.
Maybe another cloud providers in the roadmap.
As I mentioned, it's open source. Our goal is just like
okay. You welcome for a pull request. Okay.
Yes. Yeah. As usual.
Thanks for the interesting talk. I'm curious if Karpenter can fall back. It's kind of edge case, but anyways, let's say you're using spot instances and AWS region run out of spot instances, can it fall back to on-demand instances? And also, is it true for architecture? I understand it's a different kind of images for AMD 64 and ARM, but can we, let's say, if ARM instances run out of capacity, can we provision on AMD 64?
I will start from the second question. If your application is not ready for IRM or like opposite, you will not able to run it. So first of all, you have to just like depends on the compilation. Just like you have to prepare your application for ARM. Yeah. Yeah. So in this case, just like if you don't have capacity for ARM, sorry, just like I believe you will not be able to run your application use containers, the same container. If you prepare your application to run as a boss, I believe you can do some workaround. From first question, just like spot instances, and if I want to migrate everything to on-demand, it's really edge case, I believe, and in this case, I think you have to configure your provision, to like reconfigure your provisioning and restart your application.
Actually, our client running around 6,000 spot instances, and I believe it was at Black Friday or another, it was maybe some disaster or something else. It was at point there were kind of run out of spot instances.
Karpenter will try to find some another instances, of course, but if it's not available, you can say for my provisioner, I am prefer to use both spot and on-demand, and Karpenter will calculate what's the best price for you currently. If you say it's like in array, spot and on-demand at the same time, so Karpenter will understand like, okay, currently I have available this instances, it's spot instances, is it cheaper, but just like I know in 1 week something happened, I don't know, Black Friday or something else, and this instances in spot version is not available, but available in on-demand, and we'll provide for you on-demand, yeah.
Okay, thanks.
You're welcome.
Victor, I think it's time to choose the best question.
Best question. Let's choose this person related to the limitation, networking or not behind, just like this one.
Okay, thank you very much.
Thank you.